computers can be weird. Where you at in class? What chapter?
We're doing translations and stuff right now.
Weird. Yeah, I got another student that's doing that too. You totally. They skipped going from chapter 3 to chapter 4. Let's see if I still have my files. I don't have them, but I've got a bunch of translation. You're doing translating polygons, right? Reflecting over the x-axis, reflecting over the y-axis, and reflecting over a line.
Mm-hmm.
Well,
those dilations and rotations.
Yeah. My other student wasn't doing rotations, but we can try that. Do you have any material? Let's see if I can.
Yeah, I do.
Go ahead. Hold on before you send it to me. Translations of polygons. Tell me whether this is the same thing.
Yeah, this was the first worksheet we had.
Okay. You want to go over this one? Or
I think I have this one.
Got this one? Okay.
A couple days ago.
That might be the only one I had. Why don't you go ahead and take a picture of your material that you want to cover and send it to me real quick.
All right, sounds good.
Let's see, that was 10-1. Let me see. Yeah, that's the only recent one I have on translations of these polygons. Have you ever sent me a picture of anything?
Yeah, I have. I'm sending it to you now. I sent you the review worksheet from the last chapter.
Okay.
Sending now.
All in all, how's the geometry going?
Going pretty good.
Okay. Let's see what this one looks like. Well, I assume by the shaded triangle they mean this one here.
Mm-hmm.
Why are these other two on here? Oh, for the next question. Okay. So if I'm going to translate it, minus 7 horizontally and plus 1 vertically, label your answer A. What do they mean by that?
I think they mean label the shape A.
Okay, so what am I going to do to this triangle? I'll move it minus 7 horizontally and plus 1 vertically.
So you're going to move it to the left 7 units, and you're going to move it up 1 unit.
Okay, what am I going to move to the left?
The shaded polygon, or the point of the shaded polygon.
The problem with that is that's not exactly the way you're going to do the polygon. You're going to take every vertex and do that. In other words, you're going to take that point and move it 7 left and 1 up. You're going to take that point, do the same thing, and that point, do the same thing, connect your 3 dots. Then you will have a polygon that has been moved 7 left and up 1. Because if you don't do every point, then in other words, let's just take this point right here. If we move that 7 left, we go to there. If we move it 1 up, it goes to there. So that point becomes this point. But then how do we get the other 2 points? Well, you got to do the same for all your vertexes. Anything connected by a straight line. Okay. It has been reflected over the x-axis. How would I do that? In fact, here, let me open up.
You take each point and make the y negative.
You're no fun. Okay. It has been rotated 90 degrees around the origin. How do you do that?
Teacher wanted it counterclockwise, so you would reverse it.
They don't say in here whether it's clockwise or counterclockwise.
I clarified that with my teacher, and she said she wanted it to be counterclockwise. So you would reverse y and x, and you would make y negative.
Sounds like you have it all memorized down pretty good. Let's make sure that you know what we mean when we rotate it. The way we're going to do it is we're going to take any of the vertexes, but I'll take that one. I'm going to connect it to the origin with a straight line, and then I'm going to rotate that clockwise?
Counterclockwise.
Counterclockwise. So that that straight line is now at a right angle between my other straight line. And I'm going to rotate the entire thing. And you could use this principle on any of the vertexes. In other words, I could rotate that straight line 90 degrees or that straight line 90 degrees, and each one would end up pointing to the new vertex. What did you say the answer was? Yeah, what did you say the answer was?
I've not done the sheet yet.
Okay. What you really need to do is come up with the coordinates of the 3 vertices after the rotation. Okay, in other words, that's the only kind of answer you can really come up with. You can't just say rotate the whole thing 90 degrees. That doesn't answer it. In other words, after you rotate it 90 degrees, it looks to me like you have some sort of figure like this. It's not quite right, but let's put some labels. First of all, let's label that. What's that vertex? 1, 2.
Mm-hmm.
What's it going to be on the after rotation?
-2, 1.
And we're going to essentially do that with all 3 vertices. In other words, if it's kind of nice to put A, B, C so that I can write A prime, B prime, C prime. What are the coordinates on B? Not B prime, but B.
2, 5.
On B prime?
-5, 2.
Okay, so it's clear to me you know how to do C also. Okay. And the fourth part of that is to reflect it over the line y equal x. Now, let me erase this one. Reflecting over the line y equal x, that's a line that is 45 degrees, basically.
And you just reverse the points.
Okay, so A prime is what? 2, 1?
Mm-hmm.
Okay. The reason reflecting over y equal x is so important is that's the definition of an inverse. In other words, if I say, here's a function, what's its inverse? Well, its inverse happens to be y equals square root of x, but if you were to graph these two, one is a reflection over the line y equal x. And inverse is a huge principle in mathematics, all the way up through calculus. Calculus is differential calculus and integral calculus, and one is just the inverse of the other. So reflecting an object over that line, y equal x, is something that, oddly enough, you have to do a lot when you're dealing with inverses. Okay, how can we make the shaded triangle look like E? Look, in other words, look like that triangle of E. First of all, can we do it with strictly translations?
No.
So we're going to need a rotation of some kind.
Probably a 90 degree and then translate it from there. Or what, we don't know what a 90 degree looks like on the...
That's an interesting answer. That's actually, I think, the right answer. You want to take a 90 degree rotation counterclockwise and then reflect it over the x-axis. I think, let's see, if we do the 90 degree rotation, this point becomes right there, right?
Mm-hmm.
Instead of 1, 2, no, it becomes, instead of 1, 2, it becomes negative 2, 1. Now hold on. If you reflect that over the y-axis, then this point becomes that point. It's still not going to become this point when you reflect it over the x. So I do believe we've got more than just a reflection here. Yeah, we can't come up with E by doing 2 reflections. In other words, one reflection would put that point there, but this point is only at -1 on the y-coordinate, and that's not going to work. So we probably have a rotation going on here.
Mm-hmm. Yeah.
And
Did I say reflection or did I say rotation?
No, I think you said a rotation combined with a reflection.
I thought I said translation.
Ah. So if you do a reflection over the y-axis and a translation down 3, that's it, huh?
Yeah.
Did you just see that, or do you have all of these relationships memorized?
Oh.
I think that's right. If I do a reflection over the y-axis, this point becomes that point, which means I got to move it down 3 to get to this one. And this point becomes that point. Ooh, no, that's not going to work. No, translation doesn't work. Let's see if we can figure it out by putting coordinates on it.
Well, what about...
Because you have all of that memorized. In other words, first of all, I can't believe they didn't label this with points.
What about a 90 degrees clockwise rotation? And then a reflection over the y.
Well, I don't know. Let me label these points. Let's call this A, B, and C. A is 1, 2. B is 2, 5. and C is 3, 4. And on the other end, A prime is, oh, I see what they've done, minus 2, 1. B prime is that right there and that right there. No, it isn't. That's B prime. So B prime is minus 5 minus 2, and C prime is this point, which is minus 4 minus 3. All right, we can see the relationship between each of those. In other words, to get from A to A prime, we switch the numbers and change the sign on the x coordinate only.
Okay.
To get from B to B prime, we did the same thing. We switched the order and changed the letter. That's minus 2. In fact, A prime is all minuses. So we do two things. We switch the numbers and we switch the signs. That's all we did.
Oh! Oh! It's a reflection over the negative x.
You're right. Absolutely. If I draw the y equal negative x and reflect over that, that's exactly what I get. And when you reflect over positive x, you merely switch the numbers.
So when you reflect over the negative x.
In other words, if I wanted the coordinates in the previous problem, when we reflected over the line y equal x, what we're going to do, because that's the inverse, you merely switch the x and y coordinates. In other words, in the previous problem, A prime would be 2, 1, B prime would be 5, 2, and C prime would be 4, 3. That's reflecting it over the line y equal x. Well, when you reflect it over the line y equal negative x, that line there, you switch the numbers and the signs.
Mm-hmm.
That's very good. How'd you just have them all memorized? This is one thing, oddly enough, I've never memorized for geometry. Every year when I come up against these transformations, I have to figure it out all over again. You have it memorized?
Just kind of clicked.
Yeah, it seems like it. But, yeah, you got this stuff down good. That's exactly what E is a reflection over the line y equal negative x. Now, almost seems to me like that should be the same thing as a reflection over y. No, but it isn't. Yeah. No. Okay. And take the shaded triangle onto the triangle F.
Okay, so...
Now the thing to notice here is what happens to the right angle. In other words, we can tell that that's A and that's A prime, okay? Can you see my little hand here?
Yeah.
When I point? I mean, it's easy to tell that if that's A prime. but figuring out B and C is a little more difficult. So make B, or actually make C, the point that's close to the right angle, because then we know that that is C prime.
Mm-hmm.
Well, how am I going to get this to this?
Mm-hmm.
Notice every line is perpendicular to one another. What do we have to do in order to have that happen? In other words, this line right here is perpendicular to that line right there. This line right here is perpendicular. What is? What'd you say?
90 degrees counterclockwise rotation.
You got it. Describe the single transformation that has the same effect as rotating a shape 90 degrees clockwise around the origin, then reflecting the result over the x-axis.
That would be, wouldn't it be a 270 degree counterclockwise rotation?
No idea. Hold on. Let's see. So if I were to take a right triangle, the easiest shape, like that, and I rotate it clockwise about the origin, then all my lines are parallel. This becomes right there. I'm terrible with these. I really am. That's not it. Hold on. Let's make this a right triangle, but let's make it one that has a very short side and a very long side, like that. Okay, now if I rotate that 90 degrees, then the short side comes out right there. The long side, or the hypotenuse, comes out there, and it comes out there, okay? So, correct, that's the 90 degree rotation?
I believe so.
And then now they want to reflect over the x-axis, which is going to become this. So how would I take the original figure and turn it into that?
Single transformation.
Uh-huh.
Is there a single transformation that can do that?
I think so. I think a reflection over the line y equal x will do it.
Oh, okay.
Right? In other words, this point's the same point, the way I've drawn it.
Yeah.
This point becomes this point, and this point becomes this point here. So, yeah, I do believe a reflection over x does it.
Yeah.
These are tough. These require something I've never been particularly strong at, which is spatial geometry. I've always been very good at two-dimensional geometry, and this is two-dimensional geometry, but this is where it starts becoming difficult for me, is rotations, because you kind of have to be able to imagine what something looks like in space. And I've never been particularly good at that. I'm not real great at three-dimensional geometry. And I've always been good at games of, some games I'm not good at, like chess. And they say that what you need to be good at chess is a very good three-dimensional capability, geometric capability. So different people have their different skills. But yeah, the best way to handle these is
It's just very easy for me to imagine.
What's that?
It's just very easy for me to imagine like where stuff would go as
That's
like an
terrific. That's a fabulous ability to have. It really is. But I don't know if you've memorized what happens to the x and y coordinates. In other words, the only one that I know right off the get-go is if you reflect over y equal x, you just switch your coordinates. Whatever your original coordinates were, switch them. In other words, if this is 5, 1, then this is 1, 5. Okay? So I know that, and I know that if you reflect over the x-axis, then you change the sign on the y. If you reflect over the y-axis, you change the sign on the x. And that's the only 3 things I've memorized. I guess now, if we reflect over y equal minus x, we can say we switch the x and y coordinates and we change the sign on them also. You change the sign on x, but you wouldn't want to change the sign on y, would you? Oh, yes, you would, yeah. Now, if we were reflecting over that line there, we'd be in the 3rd quadrant. So everything would be negative. Okay. I wonder why Chatfield is doing this. You don't have any idea what's coming up next, do you?
No, I don't.
Is it congruent triangles? Because in the book, when you go from perpendicular and parallel lines, the next chapter is congruent triangles, which is a very important subject in geometry. In other words, that's really key. So I'm kind of surprised that they're doing everything out of order, but no problem. Okay, well, sorry it took so much longer than our normal session, but I don't think we started like 15 minutes late at least. So, all right. Well, Cole, sounds like you're doing fine. I will talk to you next Monday.
Talk to you next Monday.
All right. Bye-bye.
Bye-bye.